In this question, we are going to solve truss 1 and 2 with the link AB and DE. And we need to find the reaction at the support of AY and AX. Also, we need to find the reaction of CX and CY and EX, reaction of EX and EY. Okay. So if you take the moment at A, you're going to be left with Cx, okay, not Cy, because Cy is passing through A, exactly through at A. So you're going to left with Cx and Ex and Ey. And if you take the moment at C, you're going to be left with Ax and Ey and Ex. Ay is passing also through C. And if you're going to take the moment at E, you're going to be left with the reaction of Cy and Cx and Ax and Ay. So we can't try to know how to solve it, except we do break. So we need to do break the link. This is hinge. So we need also this one is hinge. So we need to break at truss 2. Truss 2 need to break it. So if I take truss 2, okay. So truss 2 is going to be like this. Okay. It's going to be like this. This should be. I will take the external force for truss 2. Okay, let's link it with D. Okay, this link, and I have here E, which I have EX and EY. I have here 60 kilonewton, and I have here the external load of 24 kilonewton. At B, within I have 2. I have, remember this, I have 2 internal reaction at B. So let's take the upward one, it's BY, and let's take the left BX. Okay. So can we find the reaction at B1 and Bx? If I take moment at E, I will be left also with the B1 and Bx. So we have 4 unknowns. So I need to also to try to split. So let's split the structure of link. Okay, where can link? Here's D and here's B. So I split the structure. I will say dx and dy. Okay, so let's take the moment at B. So let's say summation of moment at B clockwise, since it's passing through D, okay, equal to 0. In order to find by, so I will go with by time by its perpendicular distance, which is 20 plus 20 times 3, which is 60. So dy minus dy, since it's counterclockwise, times by 60 plus 60 times by 40. Okay, summation at d, okay, equal to 0. So dy is going to be equal to 40. Okay, 40 kilonewton. 40 kilonewton. So our assumption is right. So this is going to be 40 kilonewton. Let's erase it. Let's erase it. Right now, can we find bx? We can. So let's go to find. Wait. We can find by. by doing summation of f of y upward force positive. You know why my target is to find the internal hinge in order to shift to the other structure, even this one to the other structure. So it's good to find by it's upward plus 40 it's upward minus 60 it's down equal to 0. So by is going to be equal to 20 kilonewton. So by is going to be 20 kilonewton. Okay. Okay, right now, can we find the bx? No, bx is equal to dx, so we can find it. Okay, okay, summation of f of x positive is equal to 0. They will be similar. Okay, so let's shift to the other structure. Okay, we are going to be dx right, and by is 40 kilonewton. Yeah, we can find dx, therefore we can shift it to the bx with the other structure. So let's find link DE. By finding link DE, we can say summation of moment at E is equal to 0, clockwise positive. Um, so it will be 40, 40 is downward, counterclockwise minus 40 times by the length of 20. Okay, we have also clockwise of dx times by 40 times by 40, which is equal to 0. So minus 40 times by 20, which is going to be 40 dx is equal to 800. dx is equal to 20 kilonewton. So 20 kilonewton, and therefore ex will be equal to 20 kilonewton, and since this one is dy, so ey is going to be also to 40 kilonewton. Okay, 40 kilonewton upward. So ey is going here to be 40 kilonewton, and ex is equal to 20 kilonewton. So can we shift to the other part? Since this 20, so it will be 20 kilonewton of dx, it will be equal to 20 kilonewton. Then this will be equal to 20 kilonewton. So I found it, but the opposite direction. So the direction will change. It was from left, it will be from right. Then we can find bx. Okay, until now is everything is clear. Then we need to find the the internal hinge at at C. But if I find the internal, if I at hinge, we only need to spread the structure twice. So where is the structure of C? Okay, this is the structure at C. Okay, it's going to be like this. This is B. This is this is E. So, we split the structure at B, and therefore we have by and bx. Therefore by is going to be downward, which is by is equal to 20 kilonewton, and to the right, since this is left, it will be 20 kilonewton. But if I split again, then I need to find the by. Let's assume if I split again, okay, the structure. Okay, here is this one. If I split the structure again, okay, I'm left with 20 kilonewton. Okay, then downwards 20 kilonewton. This force is equal to this and this, But there is actually once I split, there is also a new structure. Okay, the third time there's a new structure. Okay, which is bx. I can see this is part one. Okay, I can say by, and if I spread the structure at a, okay, I'm going to be, this is 20, okay, kilonewton. So this 20 it will remain same for both. Okay, downward. It's also, how come? How come, guys? By is equal to uh, by. Summation of f of y is equal to 0. If I say by upward, okay, minus 60 downward plus 40 is equal to 0. Therefore, minus 60 plus 40. Uh, I forget actually to include minus 24. Minus 24. Sorry, guys. So So By is going to be equal to By is going to be equal to 44 kilonewton. So I forget to add this force also, the external force. So it will be equal to 44 kilonewton. 44 kilonewton. So this is going to be changed. It's going to be changed. It's going to be changed. Okay. So this is going to be 44 kilonewton, and to the left is going to be 44 kilonewton. This downwards is going to be 44 kilonewton. Same thing, 44 kilonewton. It's 20 kilonewton. Okay. Uh, you also have a force. Okay. Let's assume this direction bx2 and by2. Okay. This is part two. Okay. Remember, once split the structure third time. Once I split the structure third time, bx1 is not equal to bx2, and by1 is not equal to by2. Therefore, if I find the moment at if I find the moment at A in order to find bx2 and bx1, don't do it, because that's mean you say that bx1 is equal to bx2, which is wrong. If I did summation of moment at A in order to find bx2 and by2, even here if I did summation of moment at C to find uh, bx1 and by1, that's wrong, because you say that bx1 is equal to by1 y2 by2, which is wrong. Okay, by2. Therefore, it is actually hard. Let's take the moment at B in order to solve the structure. Okay, or let's find another way in order to find at A. The other good way is we can find the moment at C. If you do if you do summation of moment at C is equal to 0, clockwise positive, so I take the whole structure. Okay, it will be easier. If I take the whole structure, the truss 1, truss 2, link 1, link 2, with its force, which is external, and the supported reaction, so EX, which is 20, 20 times its perpendicular distance at C, which is 10. Then how can I figure it out? This is 40, and this is 30. 40 minus 30, which is equal to 10 meter. And then you have minus 40 minus 40 kilonewton counterclockwise. Where is here? Yeah, counterclockwise go like this. Okay, just expand it and then go counterclockwise. Time its perpendicular distance. All of this is 100 meter. and then you have plus clockwise 60 kilonewton times by 60, right? And then plus 24 clockwise times by 20, 20, okay, minus ax time by, what's the ax? Time by, how much is this? 30, yeah? No, 40, 50, time by 50, equal to 0, equal to 0. Okay, so we found out that minus ax times by 50 is equal to negative 280. Therefore, ax is equal to 5.6 kilonewton. Therefore, ax is equal to 5.6 kilonewton. And if we say summation of f of x, actually, summation, I can say summation of f of x positive. So cx positive, you have plus 20, which is positive, plus 5.6, which is positive, equal to 0. Therefore, you are left with Cx equal to 25.6 kilonewton minus. So therefore, structure should shift to the left. Structure should be shifted to the left. Okay. So here's our structure number. Here's our structure number 25.6. Okay. And now we are left with Cy and AY. How to find Cy and AY? Cy and AY. Can we find the summation of f of y? Actually, we couldn't. Uh, if we found the summation of f of y, no, we couldn't. We really need to split the structure as we did. So we need, since it is here 5.6 and upward force is ay, and here is 25.6 and upward is cy. Can we split the structure actually? Let's split the structure. Let's split the structure. Okay. I will go with link AB. So there we go. Here you have B, here you have 44 kilonewton, and here you have downward force of By is equal to By, let's say 20 kilonewton. But you also have a By1. Let's assume this is 1, okay? And you also have Bx. And here you have support A 5.6 kilonewton, upward is A1. In order to make your life easier, take the summation moment at B in order to find AY. Okay, because it will be more easier in order to find AY, because you're gonna break all of these. Because if you want to do by1 and bx1, you will say f of x. Okay, you need to do f of x in order to find bx1. Then you need to find the moment at a to find by1. It will take time actually. So let's find the summation moment at b to find ay. So ay is going to be clockwise, ay times 20, ay times by 20. Okay, therefore clockwise, okay, minus 5.6 minus 5.6 times by 20, therefore equal to 0. Answer is going to be minus 5.6 times by 20. So 112 divided by 20, which is going to be 5.6. AY is going to be equal to 5.6 kilonewton. So our assumption is right, 5.6 kilonewton. Can we find CY? Yes, by taking the whole structure right now. So we don't need to go to the other link. Take the whole structure as one. Okay, let's take the whole structure as one piece. Okay, I will delete everything right here since I found everything. Okay, let's to find CY. Let's find summation of f of y equal to 0 upward. Okay, the whole structure for whole structure. Okay, so we have upward force of Cy, it's going upward. Then we have plus 5.6 kilonewton upward. We have minus 24 kilonewton downward. We have also minus 60 kilonewton downward, and we have upward force of 40 kilonewton, which is upward, equal to 0. So how many vertical force do we have? 1, 2, 3, 4, 5. So 1, 2, 3, 5.6 minus 24 minus 60 plus 40. The answer is going to be Cy is equal to negative 38.4 kilonewton. Therefore, Cy should be equal to 38.4 kilonewton downward. Okay, so I need to change all this. Okay, so Cy is going to be downward, which is equal to 38.4 kilonewton. Okay. Right now everything is fine. We figured out with CY. Okay, to make our life easier, we don't need to break, just take the moment at B. So take the moment at B in order to find A. And as a whole structure, try to focus on the whole structure in order to find, since you know why I couldn't, why this internal load is not equal with this, it's not equal to this, since this 3. So when we split the structure 3 times, the internal for this one, let's say this is part 1 and part 2 and part 3, it's not equal. 1 is not equal to 2 and 2 is not equal to 3. But if I split the structure, okay, with this and this, let's say this is 1 and this is 2, therefore in this we can say 1 is equal to 2 since it is statically. Okay, okay, but this one we couldn't do it actually at B. And we also have 24 kilonewton. It is, we only put external force at hinge only one time, either truss 1 or truss 2 or link AB. I put it with truss 2.